In example one, you are determining the area between the curves x squared and square root x between 0 and 1. They're kind of telling you where the intersection is for 0 and 1, but this doesn't always mean that the curves are intersecting there. So you can either draw a graph of what they give you, or you can set them equal and find their intersection. So if we look at a graph of these, so x squared from 0 to 1, we've got 0, 0, 1 squared is 1, and if we went further, 2 squared is 4. So there's our parabola. And then square root of x, we've got square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And so we've got this. And so they're wanting to know the space between the curves. So that little space right in there. If we were to zoom in on this, then we're going to have the parabola starts at 0, 0, goes through 1, 1. And the square root function goes through 0, 0, and 1, 1 and does this kind of thing. And so we're looking for this area there. To find it, you're going to do the area of the top curve and the area of the bottom curve and subtract the two. So we've got them intersecting at 0 and 1. So we've got area equals the area from 0 to 1 of the square root function, the one that's on top, so the square root function, minus the area of the one that is on the bottom, which is the squared function. And so I've got the upper equation minus the lower equation. And so we're going to go through and do antiderivatives of these. So the antiderivative of x to the 1/2, you're going to add 1 to the exponent and then multiply by the reciprocal or divide by that exponent. Then we're going to add 1 to this exponent and divide by it. And then we're going to evaluate it from 0 to 1. And so I'm going to plug in 1. And minus, I'm going to plug in 0. And we get, this is going to be 2/3 minus 1/3, and then minus 0 minus 0. And so we end up getting 1/3. So the area between the curves is 1/3. In example 2, you are determining the area of the region between y equals 2x squared plus 10, so a parabola, and y equals 4x plus 16, so a line. If we think about this parabola, it's going to be starting at 10, and it's going to have a 2 in front, so it's going to go up faster than normal. And then we've got 4x plus 16, so that's going to be starting at 16, and it's got a slope of 4. So something like that. It didn't give me a range to go off of, so we're just finding where they intersect and finding the space between those 2 points. So we want to figure out where they intersect and then find the area between them, which is in here. So defining the point of intersection, you set your 2 equations equal. When they're equal, their points should be the same. So I'm going to subtract 4x to the other side and subtract 16 to the other side, which will give me -6. I can factor out a 2. And then I can split this into x minus 3, x plus 1, and set these equal to 0. 2 gives you no solution. X minus 3 gives you 3. X plus 1 gives you -1. So those are your points of intersection at -1 and 3, which means we're going to do the integration from -1 to 3. And then when you set up your integration, you want to do the top equation minus the bottom. Top minus bottom. So in my graph, which is why I draw graphs usually, I saw that the line was on top because it's got a higher y-intercept, and the curve is on the bottom because it's got a smaller y-intercept. So I've got integration from -1 to 3 of the line minus the curve. And so this is the problem we are solving, and we want to simplify that as much as we can before we go in and find the antiderivative. So that's going to be 4x plus 16 minus 2x squared minus 10 if you distribute your negative. Let's put it in descending order. So, and we're going to put the 16 and the 10 together. We've got negative 2x squared, 4x, and 6. And then we'll go and find our antiderivative. So the antiderivative of negative 2x squared is going to be x cubed. And then you divide by 3, so negative 2/3 x cubed. Then we've got 4x, so that's now going to be x squared. 4 divided by 2, which is 2. And then 6 is going to get an x on it. And we're evaluating it from -1 to 3. And then, so we're going to take this antiderivative and plug in the 3 and plug in the -1 and subtract those two answers. So if I plug in 3 to all of these, I end up getting 18. Minus, if I plug in -1 to all of these, I end up getting negative 10/3. And so we add those together and we get 64/3 for the final answer.